Okay, the last story I wanted to do is the Japanese asteroid mission, which has been at this small asteroid, Ryugu, for about the last year. It's orbiting the asteroid. The Hyabusa-2 mission is designed to touch down on the surface, collect samples, and then bring them back to the Earth for study. And this is a close-up view of the asteroid itself. It's only a couple hundred meters across. It's actually a very small object. It's like two and a half football fields or soccer fields across. And this is just to give you a scale for it in Paris. I guess we really should redo that for Denver, but nonetheless, there it is. And this is an artist view of how the sampling works. It slowly descends to the surface. It has this funnel that extends. When it touches the surface, there's a little sort of a bullet gets fired out of the center of the funnel, impacts the surface. It sprays material back into the funnel, and it gets put in a little canister, and then here's the return capsule that will ultimately bring it back to the Earth. And so they've already done that once. Back in February, they succeeded in collecting a sample, they believe. And then the next step was to actually make their own crater. And we talked about this a couple months ago. It happened in early April, but there's this separate little device that got released called the Small Carry-On Impactor, or the SCI, and it just, they get within tens of meters of the surface, release that, and it slowly falls under gravity to the surface. When it's just above the surface, it has plastic explosives on board. It explodes and fires a copper slug into the surface and makes a crater that's potentially several meters across. And then the idea was they would come back and sample material that had been blown out of that crater, and that way they get material that would be from subsurface rather than material that's possibly been altered by the solar wind. And so this is just a view of how that the SCI works. There's an explosive, there's a copper plate that gets smashed out into the surface, and that's what provides the energy to form this crater. And so very near the center of this view is where they were targeting the crater. Here's a view from the mothership right after they'd released the SCI. And I think here's a time-lapse view from the mothership again as the SCI falls away. And what they ended up doing after they released it is they sort of quickly raised the distance from the surface of the mothership and moved off to the side so that they didn't get sprayed with material from the explosion. This is what the cratering event might have looked like if we were there with our own eyes. But here's what it actually looked like. Here's the edge of the asteroid. Inside this inset box here, you can see a spray of material rising off the surface. So they did succeed in hitting the surface, and then subsequently they orbited back over the site. And so this is a before view, and it's very fuzzy, and there's an after view. So you see, this is the crater that was formed, and the dark material is where it blasted subsurface material out. So it's darker than the normal surroundings. Okay, so over the last 2 months or so, they started preparing to do this second touchdown and sample retrieval. And the one thing they do, they have these little target markers, they call them. They're about this big. They're covered in very reflective little mirrors. They position themselves, or the mothership, just maybe 8 or 10 meters off the surface. They drop one of these where they know that they want it, and it just slowly settles to the surface. And then as they're preparing to do their sample retrieval, the mothership has essentially flash bulbs on board, or electronic flashes that pulse, and you get a reflection from the target marker, and they can see that with their onboard cameras as just a bright spot. They know where that is, and then they figure out, okay, I want to be 10 meters off to the side from where that target marker is, and they've got sort of artificial intelligence on board that navigates them down to where they want to be. And so here's the results from the 11th of this month. And so here's the crater, and the target marker, I think, is right there. That's the bright thing. And this is their target for the sample collection. So this is a time lapse of images returned as they descended to the surface. So here's the sample horn. This is the shadow of the solar panels. This is the final 8 meters of the descent. And here's where it touches down. They blast the little bullet into the surface. You get lots of material floating away, and it worked. So they have every expectation that they successfully collected another sample. This is just a slower view of that final, well, actually it's not slower, it's just a repeat. And so now that you know what to look for, you'll be able to see it. And as soon as they touch down and that bullet gets fired, then they use their thrusters to pull back from the surface and ascend to something like 5 kilometers away from the surface. And so they've collected 2 samples. They actually have the capability to collect a third one, but the decision has been made that they're satisfied with the 2 samples they already have. They don't want to take the risk of going for a third one and having something happen to the spacecraft. Anytime they get close to the surface, they're very worried that the attitude of the spacecraft shifts a little bit. The surface is very irregular. The shape is sort of like a diamond, and it's rotating under the spacecraft, and so you don't want to have the solar panel hit a boulder or something like that. So they're going to continue for till roughly the end of this year surveying the asteroid, and then they fire their onboard thrusters to return to the Earth. And this is what that will look like. So there's the mothership, there's the sample canister, and that will be the end of the mission. The plan is that the canister comes down in the Australian outback, which is the first version of this spacecraft in 2014. They successfully recovered that with just a few dust grains from the asteroid that mission went to. This time they expect they'll get several tens of grams of material, which still isn't very much, but it's going to be very precious. So, yes?
Do they know how much that might nudge the asteroid, maybe?
So, especially the impact experiment, is that going to change the rotation or change the orbit of the asteroid. A little bit, a very little bit, but I think it's an undetectable level of change. There is a mission planned for the next decade where they'll actually be, excuse me, positioned to do this, where they have a much larger impactor. They smack a very small asteroid that's maybe 10 meters across, and then have a spacecraft observing it and see what the effect is. That's, I can't remember the name of the, well, the asteroid is called Didymos, and it's got a very small moon, and the moon is called Didymoon. So we'll hear more about that as the time approaches.